Hey everyone, and welcome. We are jumping right in today. If you've ever stared at a massive list of business requirements and just thought, how in the world am I supposed to turn these plain English requests into actual rock-solid system design? Well, you are in the exact right place. Today, we're decoding the art and science of translating what a business wants into the structural foundation of your system design. We'll be pulling some incredible insights from core texts on software architecture to make this whole process crystal clear.
Okay, here's our roadmap for this explainer. First, we'll look at moving beyond business requirements. Then, we're defining architecture characteristics. After that, we'll tackle the silicon sandwiches kata, explore explicit versus implicit characteristics, see how to protect our systems with fitness functions, and wrap up with some key architectural takeaways. Let's dive in.
Section 1. Beyond Business Requirements. To really get a handle on this, we need to draw a clear line between two concepts. On one side, we have domain requirements. This is the what. What does the application actually do? It calculates taxes, it processes insurance claims, or maybe it just lets you buy a sandwich. But as architects and system designers, our focus today is exclusively on the other side, architecture characteristics. This is the how. How does the system run? Does it need to be blazing fast? Does it have to handle 1 million concurrent users? Does it need military-grade security? Business requirements dictate the domain, but it's the architecture characteristics that form the critical structural constraints of the entire system.
Section 2. Defining architecture characteristics.
So, what exactly is an architecture characteristic? Well, formally, it's defined as a non-domain design consideration that influences structural design and is absolutely critical to the application's success. Now, you might be used to calling these non-functional requirements, but honestly, the industry is rapidly moving away from that term. Why? Because it's kind of self-denigrating. Calling something non-functional makes it sound like it's broken or just an afterthought, and that makes it incredibly hard to convince management to invest time and budget into it. So instead, we refer to them as architecture characteristics, or more playfully, the abilities.
Let's ground these abilities visually. When you're designing a system, you aren't just hooking up a button for a user to click. You're building the underlying structure to support specific operational realities. We're talking about crucial pillars like auditability, performance, security, and scalability. These are the cross-cutting structural elements that literally hold your system up under pressure.
Section 3. The silicon sandwiches kata.
So, a kata is actually a martial arts concept. It's a training exercise focused on perfecting form. And the architect Ted Neward brilliantly adapted this for software, creating exercises to practice pulling these architectural characteristics out of vague problem descriptions. Here's the basic business premise for our kata today. A national sandwich shop wants to enable online ordering in addition to its current call-in service. Users will place their order, then be given a time to pick up their sandwich and directions to the shop. Oh, and there are also plans to expand overseas and offer daily local promotions. Sounds like a totally standard, plain English business request, right? Let's reverse engineer.
Let's actually walk through this translation process. Imagine a business stakeholder says, hey, we want to offer local daily promotions. As an architect, you translate that directly into the characteristic of customization. You might need a modular architecture, where the core system handles the basic ordering, but local promos can plug in dynamically based on the user's location. Then the business says, give the user directions using external mapping. Boom. You immediately write down reliability and integration. If that third-party mapping API crashes, you definitely don't want your entire sandwich shop going down with it. And finally, expand overseas. That literally translates to internationalization, often abbreviated as I-18N, which dictates how you're going to handle different currencies, time zones, and languages. You are taking everyday business speak and turning it into hard technical constraint.
Section 4. Explicit versus implicit characteristics.
There is a massive structural difference between what we are explicitly told to build and what we are simply expected to know. Explicit characteristics are those specific, written-down requests, like, say, a system needing to handle 1,000 concurrent users. But then we have implicit characteristics. These completely shape the structural aspect of the design, but they aren't written anywhere. They come solely from your internal domain knowledge as a seasoned architect.
Let's look at a few of these implicit ones. Think about availability, reliability, and security. I can guarantee you no business stakeholder is ever going to hand you a formal document that says, oh, by the way, please make sure we don't get hacked, or please make sure the system doesn't crash. They just assume you'll work that magic. But missing these, it leads to absolute nightmares. A great example from our sources is the SysOps Squad ticketing system.
It was this massive, monolithic application where customers couldn't even get support because the system kept dropping connections. It failed completely because the architects didn't implicitly design for basic reliability and availability.
Which brings us to a crucial point, the trade-off. You simply cannot support all architecture characteristics. It's impossible. If you try to design some generic magic bullet architecture that supports maximum security, maximum scale, and maximum customizability all at once, you're going to end up with an overly complex, wildly expensive mess before you've even solved the core business problem. Prioritization is absolutely mandatory here. You have to sit down with stakeholders, pick the top 3 most important characteristics, and frankly, accept that you are intentionally not optimizing for the others.
Section 5. Protecting with Fitness Functions.
The book, Software Architecture, The Hard Parts, gives us a really strict definition for architectural fitness functions. It defines them as an objective integrity assessment of some architectural characteristic. Now, this is totally different from a unit test. Unit tests validate domain criteria, like whether a math calculation is right or an address is formatted correctly. Fitness functions validate the architecture itself. If you write a test to ensure that a sudden massive burst of users doesn't crash the server, checking the elasticity, that is a fitness function.
So how do we actually make sure our architecture doesn't just slowly degrade over time as developers pile on new features? Simple. We automate it. By embedding these fitness functions directly into our CI/CD deployment pipelines, we are constantly testing our structural integrity. For example, if page load time is one of your prioritized characteristics, you write a fitness function that literally stops a code update from launching if the load time exceeds a certain threshold. Or you might use code analysis tools to fail a build if a developer accidentally introduces a forbidden dependency between modules. You are setting up an automated guardrail to protect the system's structural constraints.
Section 6. Key architectural takeaways.
Let's pull this all together into a final strategy. First, always clearly separate your domain requirements, the what, from your architecture characteristics, the how. Second, actively translate those plain English business needs into concrete abilities, like customizability or scalability. Third, use your expertise to sniff out those crucial implicit characteristics that stakeholders just forgot to mention. Fourth, embrace the trade-off. Limit and prioritize your characteristics based strictly on business value. And finally, don't let all your hard work rot away. Protect your design using automated fitness functions.
I want to leave you with a really high-impact question to audit your current work. Which ability is your architecture secretly missing right now? Is your team blindly pushing out features while the structural integrity of your system quietly degrades in the background? Take a hard look at your latest requirements document and see if you can translate the business needs into the real architectural characteristics your system actually demands. Thanks so much for joining me on this explainer,